So before we solve number 19 here, let's go through a basic a refresher course on the SOHCAHTOA. So SOH, CAH and TOA. So if you have a right triangle and let's say this is your angle X, the side opposite to that is O, adjacent to that is A, and the side opposite to the 90 degree of course is the hypotenuse. So sine of X will be always opposite over hypotenuse, from which comes the SOA, so then cosine will be adjacent over hypotenuse and the tangent of X will be opposite over adjacent. That's how you get the SOHCAHTOA. Now in this particular case, they said sine of X is 4 over 5. So if we draw this triangle and this angle is X, sine of X would be opposite over hypotenuse, right? So the hypotenuse here must be equal to 5 because that's coming from SOHCAHTOA, right? Hypotenuse 5, opposite is 4. So opposite is equal to 4 and hypotenuse is 5. And then the adjacent side for this angle X is equal to 3, right? Because it's a 3, 4, 5. You can use Pythagoras theorem to find out that this is 3. Now let's put a name for this triangle, PQR. So the point is, if you got angle R as 90 degrees, angle Q as your X, then angle P has got to be 90 minus X. That's a property because all three must add up to 180 degrees. So now if I'm trying to find the cosine of 90 minus X, I know it has to be adjacent over hypotenuse from SOHCAHTOA, right? This one. So the adjacent side for 90 minus X would be this 4. Not this A, but this, because that's adjacent to 90 minus X. So that would be 4 and the hypotenuse remains 5. So your answer is 4 over 5. Now, there is a property of complementary functions which says that if you have a sine of X equals cosine of 90 minus X, like we just proved, then sine and cosine are complementary functions. Similarly, sine of 90 minus X is equal to cosine of X. If these two hold, then we call them complementary functions. And I write it this way, okay? Sine and cosine are complementary functions. There are two other pairs of functions which are also complementary. You should memorize them. First one is tangent and cotangent pair. And the third pair is cosecant, which is 1 over sine, and secant, which is 1 over cosine. So all these three pairs of functions are complementary functions. So in the actual test, when I see a problem like this and they tell me I have sine of X equal to something, what is cosine of 90 minus X? I know from this property of complementary functions, I know that sine and cosine are complementary functions, so I'll know that sine of X will be always equal to cosine of 90 minus X. Or for that matter, if they give me cosine of X, I'll know that will be equal to sine of 90 minus X. I will not do all this extra work. I just remember the complementary functions and their properties. I just wanted to show or derive this property for complementary functions for you.